Hello, and welcome to Solving for the Undefined podcast. I'm your host, Johanna, founder of Miss Kuiper's Classroom, the place that equips teachers and parents in helping students struggling with on-grade level math. But it's not always about the numbers, and that's why I'm here, bringing you the formulas to solve your problems, math and otherwise, and helping students gain confidence in academic abilities. And that's what you can count on. Hello, happy new day to you. I'm so excited to be back with a brand new episode. Today was assessment day for my Math 8 students. We're finishing up linear equations, specifically finding y-intercept, slope, and then therefore the linear equation from positive slopes and negative slopes. And we also briefly talked about zero slopes, but we aren't going to get into vertical slopes, not at least in Math 8. As we were doing this today and I was bringing up the assessment, I was wondering how many scaffolds do I put into this assessment without taking away the academic rigor, but still providing them the opportunity to show what they have learned. So it got me thinking, how do I scaffold activities without taking away academic rigor? And my goal in Miss Kuiper's Classroom is to help students struggling with on-grade level math gain confidence in their academic abilities through scaffolded resources. Or at least one of the ways is through scaffolded resources. To start us off, what does scaffolding mean? I want you to picture a building that is being built, and usually along the sides of it, you'll see these structures with wooden platforms that sometimes have tarps all over them. It kind of looks like it's almost holding up the building. Now, these are the temporary platforms to support workers during construction. Similarly, scaffolds within a classroom move students progressively towards better understanding and stronger understanding to ultimately give them independence in the learning process. But my problem today when I was looking at our linear assessment was how much scaffolding do I provide these students without taking the academic rigor? And I had to think about it. What was my goal? At our middle school, we do what's called proficiency-based teaching and learning, or PBTL for short. Not to be confused with PBL, which is project-based learning. So proficiency-based teaching and learning is just teaching specifically the standards and assessing them based on full understanding, mastery, proficiency, working towards the standard, and needs improvement, I think is the last one. I've been teaching this for 2 years, you'd think I'd know. But on a 4-point scale, showing how well the student understands the topic. When we first started doing this PBTL work as a math department and as a data team with my Math 8 teachers, we had to look at this Common Core standards and see, what are we teaching? What is the goal? So let me read you the standard that we were working on for the past couple weeks in my Math 8 classroom. So this is Common Core State Standard 8EE6. So it says, use similar triangles to explain why the slope m is the same between any two distinct points on a non-vertical line in the coordinate plane. Derive the equation y equals mx for a line through the origin, and the equation y equals mx plus b for a line intercepting the vertical axis at b. With this standard, our goal is for our students to be able to come up with the equation either y equals mx or y equals mx plus b for any given linear equation that is not a vertical line, which is why I said earlier that we touched on positive, negative, and zero slopes. We didn't talk about vertical slopes, although I did show them the slope dude video. I don't know if you've seen that, but it's this YouTube video made a very long time ago. Probably not that long ago in the grand scheme of life. It shows a skier on this adventure. And going up the hill, he goes puff, puff, positive, puff, puff, positive. Coming down the hill, he goes nice, negative. On the flat part, he goes, this is zero fun. And then he gets to the vertical portion where he falls off the edge and says the worst curse word in all math and algebra, undefined. My students have a love-hate relationship with this video. They benefit from the information that's portrayed. It's very visual. It helps students understand from left to right, is the slope positive, negative, zero, undefined. I showed them that video so they were exposed to what undefined is for a vertical graph, but we didn't touch on it besides that. With linear equations, we talked about how to find a y-intercept, how to find slope, but we did this in a very strategic order. What we did was we started out with a single quadrant graph where the line started at the origin and went in a positive direction. From here, we talked about lattice points. I love the term lattice points. It helps us visualize where our linear equation is going through the grid lines on our graph. Because we are doing online learning right now, I was using Jamboard. And what I originally was planning for was not how it turned out, but the way it turned out actually benefited my students more than what I originally had planned. I was using Google Jamboard, and there is this tool where you can create a shape. I was going to use the circle to kind of denote where all of our lattice points were on our linear equation, our line. And so I dragged it out, made the circle, and what I intended to do was make it small enough so it looked like a single dot, and then duplicate that to be all of the lattice points on our graph. However, Jamboard only lets the dots be so small, so it ended up being a little circle. And I was like, no, I'm gonna have to use the pen and try to draw circles, and it's gonna look funky, and I'm a perfectionist, and everything has to be perfect. But then the idea came. Why not make the circle transparent and we circle our lattice points instead of putting a dot on them? So I ran with it, and I loved it. Because when you have a circle that is transparent, it highlights the fact that the line goes perfectly through the grid lines on the graph, which helps students visualize and see and understand what a lattice point was. And then for students who are still struggling to understand what I was talking about, I zoomed in on the graph and I took the circle and we just went up on the line. And every time we came to a vertical grid line, now this might be hard to visualize, so I apologize in advance, but stick with me. So I used it as kind of a microscope. I took the circle and I started moving it up the line. And every time we hit a vertical grid line, I would ask, lattice point, yes or no. And if the linear graph went through the grid line, both the horizontal and the vertical, my students would say, yes, lattice point. But if it only went through the vertical and not perfectly also through the horizontal, they would be like, no, not a lattice point. And they were beginning to understand and grasp what it meant to be a lattice point. Inadvertently, I created a scaffold for my students to better understand what a lattice point is. Now, I call this kind of scaffold a tool to help students progressively towards stronger understanding and ultimately an independence in their learning process. Because soon, they're going to be able to see those lattice points without having to take our yellow microscope and move it along the line. Giving students yellow microscope circles on their assessment is not going to take away from the overall goal of the standard. To be able to derive the linear equation y equals mx or y equals mx plus b from the graph, because the lattice points are just a piece of the puzzle that they have to figure out in order to create that equation. And talking about these yellow lattice points kind of segues us into talking about what scaffolds can you use within your classroom that don't take away academic rigor? Going all the way back to the time when you first present a concept to your class. What I like to use is guided notes. And I split these guided notes into 3 parts. And you may have heard these before. I split it into I do, we do, and you do. So an example of this is for my domain and range notes that I did with my Accelerated 8 group that are doing Algebra 1. Our guided notes are stepping us through problems as we go. I'm not a huge fan of presenting the notes first and then applying it to the problems. I like to have it side by side. Notes on one side, problem on the other, kind of like a split screen but on paper, but it was online learning, so online paper, you get the picture. The notes, the guided notes, they're mostly done. They're mostly complete. And I, as the teacher, it's the I do, so I'm presenting the information. With this problem, the first one is telling the students to find where the graph begins and where the graph ends. And then it asks them to label those. What number for the x values is it starting at, and what x value is it ending at? And that's the only part they fill in. And then they highlight everything in between on the x-axis. And it walks them through how that is the domain. The x-axis from where the x values from where it begins to where it ends. That is the domain for a finite graph. And then it walks them through the exact same steps for the range. And that's the I do problem. They're seeing it, we're reading the notes, we're talking about how it relates to the graph, and they do 3 things: the beginning, the end, highlight. Then comes the we do. Now I've taken a little bit more of the scaffolds out, so they actually have to draw where it begins, where it ends, and bring it to the axis. Then they highlight, then they label, where does it start, where does it end, and then we put it into algebraic notation. And then comes the you do. The scaffolds are taken away. They're given the step 1, the step 2, the step 3, and then they get to do it on their own. So guided notes are a scaffold you can use within your classroom to help students understand the process of it. Another scaffold is fill in the blank problems. I really like this one, especially when you're teaching solving for the value of x, when you're teaching Pythagorean theorem, anything that has a computational aspect to it. Fill in the blank problems are awesome. So as you go through, again, it's an I do, we do, you do. So the I do is a mostly complete problem where we walk through what is happening and we label it on the side. Then the we do, maybe some of the numbers are missing and students have to fill in, what are we doing here? And then the you do, where it's a pretty much blank problem and they're doing every step on their own. But they already have 2 problems they can refer back to, the I do and the we do. So fill in the blank problems are an awesome way to help students gain confidence in their academic abilities, especially if computation itself is a struggle point for students. Another one is find the error. Again, I really like this for solving equations, Pythagorean theorem. You can do find the error for pretty much any mathematical concept. Students have to identify where the problem went wrong. Is it a computational error? Is it a practice error? What is going on that makes it wrong? And it helps them figure out not only what's wrong, but then why is it wrong? So they're learning it on a deeper level as they're trying to figure out where did this problem go wrong. I did a problem like this in my Accelerated 8 class when we were talking about slope. So in Accelerated 8, we go through positive slope, negative slope, zero slope, undefined slope. And I put up a linear equation for a specific graph. And it had, let's say it was y equals negative 3x plus 4. But the graph was actually showing y equals negative 1/3 x plus 4. And students have to identify that the slope is inaccurate. Instead of 3/1, rise 3, run 1, but it was actually backwards, rise 1, run 3. And they have to be able to identify the difference between those two. So not only are they learning the difference between a negative 1/3 slope and a negative 3 slope, they're learning to identify if they make that mistake, which one would be the accurate answer. It reinforces the idea that slope is rise over run. So I'm a huge fan of find the error types of problems as a scaffold to use within the classroom. And lastly, one of the other scaffolds that I love to use in my classroom is step-by-step guides. And this relates back to guided notes. However, I use step-by-step guides as anchor charts or mini posters within my classroom. Well, not this year, but in theory, in previous years. I like to use these step-by-step guides as posters within my classroom. So I pulled out one of my notebooks from last year to kind of illustrate what I mean. When talking to my Math 8 students about systems of equations, the standard we were working on was Common Core Standard 8EE7, I think A or B, I don't remember, but it's how many solutions. So does the set of linear equations, is it one, none, or infinitely many? So the guide that I use, the step-by-step, was kind of a flowchart, and I will link it into the post on my blog with this. It's a flowchart, and it starts off, are the variable terms, ... and then it goes down to the same, and it gives an example, 3x plus 4 equals 3x plus 5. And then the other side is different, question mark, 3x plus 4 equals 6x plus 4. And then it flows down into talking about the constants. Are the constants the same or are they different? And then it leads to, well, this means it's infinitely many. And this means it's no solution. And this means it's one solution. So it's a step-by-step guide for students who are learning to understand if a system of equation, is it systems of equations or is it singular system of equations? I never remember which it is. System of equations has one solution, no solution, or infinitely many solutions. And it's not labeled out as a step 1, do this. Step 2, do this. And those have their purpose within the classroom. But as a visual learner, this would be so much more beneficial to students than step 1, do this, step 2, do this. So step-by-step guides are another scaffold you can use within your classroom. And there are so many more, infinitely many more, if you will, scaffolds you can use within your classroom. But the 5 that I've talked about today are the tools, like the lattice points, the yellow circle microscopes for lattice points, the guided notes, the I do, we do, you do, the fill-in-the-blank problems, also for the I do, we do, you do, and the find the error and step-by-step guides. So going back to the original problem that I faced today in my linear equation assessment for my students, how much scaffolding do I provide without taking the academic rigor? Looking back over the time that my students and I had spent on this topic of linear equations, we had done guided notes, fill in the blank problems, finding the error, step-by-step guides, the lattice points. We had set that all up together. They had notes on it. We practiced it. We played games. We did different sorts of activities to reinforce the ideas of slope, y-intercept, linear equations, y equals mx versus y equals mx plus b, positive versus negative. All of those were scaffolds and ideas that we had worked through for the past month or two. So when it came to the assessment, they had those things already in place for them. We had built the building. This was the time for them to see if the building would stand on its own. And we'll see. As I grade them later today, we'll see how well my students did. So I chose for the assessment to not put those same scaffolds in place. They had the scaffolds ready and waiting for them in their brains from all the practice we had done over the course of this unit. In summary of everything we've talked about today, scaffolding is to help students move progressively towards stronger understanding and ultimately gaining independence in their learning process. And the scaffolds we talked about were the tools, like the yellow circles for lattice points, guided notes, the I do, we do, you do, fill in the blank problems, finding the error, and step-by-step guides. Thank you so much for tuning into today's episode. To find all the links and resources to things talked about in this episode, head on over to MissKuipersClassroom.com and click on podcast. And until next time, I'll leave you with this. Life is a math equation. In order to gain the most, you have to know how to convert the negatives into positives.